Alright, so far this chapter we've dealt with graphing systems of equations in two variables and seeing where they cross. What we're going to do in the next two lessons is graph inequalities. So what we're going to do in this lesson is just graph the inequalities, and then in the next lesson we're going to graph a system of inequalities and see what that looks like. But just to refresh your memory, an inequality has one of these symbols, less than or equal to, greater than or equal to. And remember, a solution of an inequality is the point that makes it true. In this case, since we have two variables, we're looking for an ordered pair. So first thing we're going to do is just kind of beginner level, check to see if this ordered pair is a solution, and the way that we do that is the way that we've always done it, by plugging in the value and seeing if it is true. So instead of x we put -1, and instead of y we put -9. So we get 2 times -1 plus -9, and if that is less than -3, then we know it's true. So I get -2 minus 9 is less than -3, and that is true, it's -11, so then it is a solution. Alright, so here comes the gibberish. We're going to go through the steps on how to graph an inequality, and then we'll do it. The first thing you're going to do is graph the boundary line for the inequality. And I'll explain what the boundary line is as we do it. Then you're going to use a dashed line when you're not allowed to be equal, which would be a less than or a greater than symbol. You're going to use a solid line for less than or equal, or greater than or equal. Then what you do is you test a point that is not on the boundary line, and you determine whether it's a solution to the inequality. The best test point is 0, 0, because it makes all the numbers super friendly, unless 0, 0 is on the boundary line. When the test point is a solution, then the section that has that point gets shaded. If the test point is not a solution, then you shade the half plane that does not contain the point. So what the heck does that mean? Alright, here we go. So we're going to graph y is less than or equal to 2, and our steps are graph, test, and shade. So I need my axes first. And now I'm going to graph the line y equals 2. So that's what we would consider the boundary line. You take the symbol, you just turn it into an equal sign. So the one thing that I want to do before I make the line y equals 2 is I look to see if it's allowed to be solid or it has to be dashed. So since I'm allowed to be equal to the line, then it's going to be solid, because that's what the rule up above said. So I'm going to draw a solid line, and you'll see what a dashed line would look like in a little bit. And that's the line y equals 2, because it's a horizontal line going through the y value of 2. Then I'm going to test a point. My favorite test point is 0, 0, because it makes all the work super friendly. So I'm going to take my point and plug it into the inequality up here. Now they actually only ask for the y value, so does the y value of 0, is that less than or equal to 2? If it is, we're going to shade the portion that has 0, 0 in it. If it's not, then we're going to shade the other side. So step 3 is to shade, and 0 is less than 2, so that is in the shaded section. So what you do is you just take your pen or pencil and you color in the grid all the way to the edge, but don't go over the line like I did right here. And that's it. You should probably just write the inequality nearby. Y is less than or equal to 2. Alright, this one's a little more complicated, but it's the same steps. Graph, test, and shade. So let's make our axes first. And I'm going to graph -x plus 2y equals 2. Now, I want to actually do this using the standard form technique. Remember, standard form is when you do the zeros. So I'm going to find my intercepts. My intercepts are at, let's see, when I plug in 0 for x, that would cancel out, and I would get a y value of 1, so that's the 0.01. And let me cover up the y. When I plug in 0 for y, then x would have to be -2. So I'm going to graph using this technique. So I'm going to graph -2, 0, and 0, 1. Now I'm going to look, before I make the line, I want to see if I'm allowed to be equal to the line. Since this is just a greater than sign, and it doesn't have the equal portion, I cannot be equal to the line, which means it's going to be dashed. So that's what it looks like when it's dashed. It's just like a dotted line. Now I test a point, and I can test my favorite point, which is 0, 0, because it's not on the line. And I'm going to take 0, 0 and plug it in right here. So -0 plus 2 times 0 is greater than 2. Well, that gives me 0 plus 0, which is not true. So that means that the portion that has 0, 0 does not get shaded. So I'm going to color in the side that is not including 0, 0. And last thing is just to write the inequality near the shade somewhere. -x plus 2y is greater than 2. All right, let's look at a word problem. Pause the video, read the story, and then press play when you're ready. All right, so I underlined the important things, and now let's do it. So first thing is to write our inequalities. So you can spend at most $10 on grapes and apples. So you can use X and Y, but whenever you have a word problem, sometimes you can just use the letters that represent the words, because that's easier to remember what they stand for. So I'm going to make G equal the number of grapes, and A is going to equal the number of apples. So now when I write my inequality, I can spend at most $10 on grapes and apples. Grapes cost $2.50 per pound and apples cost $1 per pound. So $2.50 times the number of grapes that I get plus 1 times the number of apples is at most $10. That means that I can't spend more than $10, so it has to be less than or equal to 10. Now you don't need that 1, that's kind of silly, so I'm just going to erase it. So I did one part, which was write an inequality. Now I have to graph it. I'm going to make a first quadrant only grid, because you can't have negative grapes or negative apples. And a lot of times word problems usually end up with first quadrants anyway. So this will be, let's make this grapes, and this will be apples. I can probably go by ones because the numbers are pretty small. And I'm going to use the intercepts technique again. So when I plug in 0 for A, I get 4 representing G, so that will be 4 pounds of grapes. And then when I plug in 0 for G, this whole thing goes away, and A is 10. So those are my intercepts. Let me plot the dots. Oh, perfect, right at the top. And I'm allowed to be equal to the line, so I can make a solid line. So I made my boundary line. Now I need to decide if it's going to be underneath the line or above the line. You might be able to figure out at most would mean it's below the line, but you can plug in a test point, 0, 0. 0, 0 will work. I'll just kind of shortcut to that. So we're going to color in right here, 0, 0, and all the numbers above it, but up to the boundary line. Now what we need to do is we need to interpret and identify two solutions. Now solutions are numbers in the story that work. So we're going to just kind of make 2 dots. So I can do 1, 1, that's in the shaded section, and let's do 2, 3. There's lots and lots of points you can pick. Those are the ones that I'm picking. So we have to interpret them, which means to explain what it means using the labels in the sentence. So you can get 1 pound of grapes and 1 pound of apples. So 1, 1 means you can buy 1 pound of grapes and 1 pound of apples. And my other point, which is 2, 3, means very similarly, you can buy 2 pounds of grapes and 3 pounds of apples. If you have any questions, write them down and ask me when you come to class.